그런데 확실하지 않으니 진짜. 네, 교수님 저희 말씀 잘 들리십니까?
네, 잘 들립니다.
네, 그러면은 발표 시작하겠습니다. Sorry for being delayed. We'll start presentation from team 2. Team 2, please come here and make a presentation. 화면 공유하시고 말씀하시고.
Good afternoon, everyone. I'm Seung-jae Lee from Team 2, and our project is policy proposal on hydrogen shake industry. For introduction, the urgency of achieving carbon neutrality by 2050, as outlined by the IEA, is steering global effort toward the continuous decrease in the use of fossil fuel, particularly in the transportation section. The vision is to replace conventional fuel with eco-friendly alternatives, and at the forefront of the transition is hydrogen. In the shipping industry, a section not exempt from these transformative changes, hydrogen fuel is anticipated to play a pivotal role. The IEA projects a significant shift towards a predominant use of hydrogen in maritime transportation. What sets hydrogen apart and why we are focusing on it extensively is its unique attribute of producing low emission to atmosphere, making it a key player in achieving sustainable and clean energy practices. And at using hydrogen, there are some problems that we got. The management of the global hydrogen supply chain requires a comprehensive understanding of the market demands, infrastructure requirements, and regulatory framework in different regions. While the vision for a hydrogen-powered future is clear, a significant obstacle looms large: the lack of adequate infrastructure. Establishing a seamless and integrated supply chain across different regions and countries demands not only technological advancement, but also a concerted effort to bridge the existing infrastructure gap. In the shipping industry, the absence of a robust hydrogen infrastructure poses a substantial challenge to the widespread adoption of this clean energy source. The scarcity of refueling station and storage facility for hydrogen vessel is particularly noticeable. To address such challenges, various initiatives are underway, such as the development of international standards for hydrogen production, storage, and transportation, as well as the establishment of agreement and partnership to promote the adoption of hydrogen as a clean energy source. However, it remains imperative to focus on building the necessary infrastructure to support the growing demand for hydrogen in maritime transportation. Our policy proposal encompasses not only the technological aspect, but also a strategic approach to fill the existing infrastructure void, ensuring a smoother transition toward the hydrogen dominant future in the shipping industry. Some of the hydrogen ship industry stands as a promising avenue for achieving sustainable maritime transportation while curbing greenhouse gas emissions. Although the technological maturity of hydrogen-powered ship is high, challenges persist, particularly in infrastructure and supply chain management. This emphasizes the necessity for policy proposal and that addresses the production, storage, and transportation of hydrogen. Okay, let's move on to the exact policies that we propose. At the production of hydrogen side, hydrogen has potential as a clean energy source. It's crucial to understand the distinctive between the various types of hydrogen production methods. It's gray and blue and green is the most widely used hydrogen. Gray hydrogen is the hydrogen produced by the fossil fuel. And blue hydrogen is hydrogen produced by fossil fuel, but it captures the CO2 emitted by the production, and it doesn't emit any CO2 to the atmosphere. And green hydrogen is the hydrogen that produced by renewable energy and doesn't emit any CO2s. It is clear that we're using green hydrogen is the best way to operate hydrogen vessel. But there is another challenge, the economic risks. As you see in the graph, this is the cost of different hydrogen. And we are in South Korea. Let's see in South Korea. South Korea's hydrogen cost is gray is about $2 per kilogram. Blue is about 3.5 per kilogram, and green is $10 per kilogram. It is very, very high and very different from gray hydrogen. So we decided that we cannot fully achieve green hydrogen in 2023. But as we see on the right side graph, the green hydrogens cost getting lower, and it becomes similar with gray hydrogen because gray hydrogen's cost must be increased because of the carbon neutrality. So we decide to make a difference in 2023 and 2030. For 2023, green and blue hydrogen is 50% and gray hydrogen is 50%. For 2030, green and blue, we regulate to use green and blue hydrogen for 100%. I think this fuel regulation may help to achieve carbon neutrality faster. And about the policy of transportation. To operate hydrogen vessels effectively, it is imperative to establish a robust infrastructure. Seamless integration of hydrogen-powered ship into a maritime landscape hinges on the availability and development of key supporting facilities. The following infrastructure elements are essential. Hydrogen refueling station for refueling the ship, and the storage facility and transportation network is essential. Our proposal extended beyond the vessels themselves. We advocate for a holistic approach that encompasses the necessary infrastructure to operate hydrogen vessel seamlessly. By adjusting these infrastructure requirements, we lay the foundation for the sustainable and efficient hydrogen power maritime transportation system. But as we see in the screen, there are even the infrastructure for hydrogen vehicle, there is a very less of refueling systems. So currently, hydrogen vehicle refueling systems are inadequate, causing a critical bottleneck in the adoption of hydrogen as a clean fuel. The shortage of hydrogen infrastructure extends to vessel refueling stations. We strongly advocate for the establishment of hydrogen-related infrastructure, considering this as a national project and urging the implementation of supportive policies. Let's move on to the storage policy section. When we store the hydrogen, it is important to get high volume density and small spaces and a large amount of the tanks. But when we use gas hydrogen as a storage method, it has very low energy density, and it requires very high pressure to increase energy density. It requires very high pressure, but it is not safe for the operation. So we are reject to use gas hydrogen as a storage method. And we thought about the liquid type of hydrogen. There are several liquid hydrogen and LOHC and the ammonia shaped storage method. As we see the volume energy density, the ammonia has the most energy density, and it requires very not that low temperature, so we decide to use ammonia. And also ammonia is stored in 1 atm as a liquid, so it is safer than other methods as storage. And comparing with ammonia storage hydrogen and LNG, the energy density is a little bit half of the LNG is ammonia. And the storage pressure is ammonia hydrogen is 1 bar, and LNG requires 7 to 12 bars for safe storage. So it is good to use ammonia in pressure sense. And the storage temperature, also ammonia storage hydrogen is -33 degrees Celsius and LNG is -160 degrees Celsius, so ammonia is better. And fuel efficiency is ammonia is higher than LNG, so it is good to use ammonia in many regions. For conclusion, our policy suggestion in production for 2023, green hydrogen is 50% and gray is 58%. For 2030, green hydrogen 100%. This is the regulation of the green hydrogen vessels fuel. And for transportation, set national assignment to provide infrastructure for hydrogen fuel. It must help to move our mankind go to the future, carbon neutral future. And the storage side, we decide to make make hydrogen in the liquid ammonia form, and we proved that it is better than LNG. Okay, thank you for your kind attention, and this is my end of my presentation.
Thank you. Is there any question, comments from other team members? No, then we can go to TA.
This is the chair. I have two questions. So you mentioned your final conclusion is that it is best to transport hydrogen in ammonia form. And you mentioned that ammonia is safer than liquid hydrogen or compressed hydrogen because of the temperature close to ambient and pressure close to the ambient state. But in my notion, ammonia has some toxicity, so it can be much more dangerous. And this is my first comment. And my question is that you mentioned that ammonia fuel has a high fuel efficiency compared to LNG. So I don't understand why is like that. Because ammonia, in my knowledge, ammonia is very difficult to combust. So we need a lot of pilot oil like diesel, and it has low efficiency. So this can be the reason why ammonia has higher efficiency than energy.
Okay, and we thought ammonia stored hydrogen is when we store the hydrogen, it's a form of ammonia, and when we use it, we change it to ammonia to hydrogen gas or hydrogen liquid. So it maybe there's some additional steps for ammonia to hydrogen, but hydrogen fuel has a very high efficiency, so the balance is better than energy.
Then I think you will consider the energy consumption that is used for conversion from ammonia to hydrogen.
Yeah.
Thank you. Next.
I have one question. So it is an interesting topic for sure, but I feel that it is not very relevant to the main theme of the class. So how would you relate this topic to ocean energy or naval architecture?
I think our proposal for infrastructure and store method must be and near the shore, and the project is for the ocean vessels. So we think making ocean vessels achieving carbon neutrality of ocean vessels, and also it requires some offshore or onshore infrastructures to achieve this. So we think this is the ocean engineering project.
And here is my comment that for me, it is still in the proposal stage rather than final presentation. Even though this is a policy proposal, you should be more specific. Say something to be a patent or a journal paper. It should be very specific and deep. Something like why you choose 2030 as 100%. The reason behind that selection and how can you achieve that target year? So that kind of thing should be answered. And one small comment is, I don't know whether you already have, but is there a definition for green and gray and blue hydrogen? Somewhere in the presentation?
Yeah, we do at the slide 7.
Where is it? Oh, the picture?
Yeah, picture, and I said about the definition.
Where is the definition?
We see in the picture of this section is the definition.
Okay, thank you. All right, let's move on to team three there. Thank you very much.
I will present the final result of our project of reacting to oil spill accidents, cleaning up. Our final presentation is about developing a service that offers oil cleaning response guideline for requested oil spill accidents from the customer. We suggest improved scenario for a response to actual oil spill accident chosen from the history based on the guide. In the past presentation, we have emphasized the importance and severeness of oil spill accidents and reaction. And we have investigated various methods of oil cleaning and presented the comparison of the efficiency of each method. And in this final presentation, as I said, we will apply a specific guideline to oil accident from history. These are the contents. So these are the general ideas of reacting to oil spill accidents. We may use data from history for predictive models, and we may use advanced technology such as AI or GIS remote sensing. And with those tools and data, we may develop an action plan considering various scenarios. And we may also establish partnership among industries and countries for efficient communication and collaboration. So who will be the customer of our service? It may be the Ministry of Environment or shipping companies, any other organization or companies suffering from or wanting to prepare for damage by oil spill. We expect that government or oil cleaning equipment companies may finance our business. This is the block diagram of explaining how our guideline works. So first, we receive the condition of accident from the customer. And based on the data from previous accidents and with the usage of method comparison score table we have developed on the midterm, we will determine the appropriate cleaning method. And with this decision, we will decide specific product type. And considering the budget of the customer, we will calculate the cost and time. And we will convey these results to the customer, and with some exchange of comments with the customer, we will able to provide the most effective scenario for the customer's requests. More simply, the guideline processes consist of 3 steps. First, analyzing the accident condition provided by the customer and suggesting appropriate cleaning method. and then suggesting effective product selection and amount of purchase based on the budget. So now we will prove our guidelines effectiveness by applying it to a particular case in history. We chose the incident of Hebei spirit oil spill, which is more familiar as Taean oil spill for Korean students. It occurred in December 2007 in west coast of South Korea, and it occurred very close to the coast, 10 kilometers off the coast. So now we will apply the first step, analyzing the accident. So the key points are that there were 4 human casualties, and the damage cost and restoration and cleanup costs are following. And it took 2 months for physical cleaning and 7 years for complete removal. We will show our improvement of these numbers. About the space-time context, for the geographical factors, there were some difficulties in that the coastline is very intricate, which caused challenge in containing and cleaning up oil. And also, since the Yellow Sea is relatively shallow, it hindered the cleanup operation. And also, at that day of accident, the weather was very harsh, including strong winds and currents. These made the containment of oil more difficult. So what they actually responded at that accident, they used oil booms and dispersant for initial containment of oil. And for the coastal oil removal, they used sorbents and buckets. But there were many difficulties due to the harsh weather and the limited cleanup resources. Now we finish the first step, we move on to the second step of suggesting the cleaning method. So according to the score table result of our presentation of midterm, it turned out for the open sea, the booms and dispersants were appropriate. And for the shoreline cleaning, skimmers and bioremediation was appropriate. But in the actual accident, these sorbents were mainly used. So we recommend that skimmers and bioremediation should be used instead. I will explain more about what problems occurred during the actual accident oil removal. Due to the strong wind, and since the booms were too weak and small that were deployed, it was difficult to contain the oils. And also at the shoreline, they mainly used sorbents and buckets, which took a lot of time and workload. With the deployment of skimmers, a faster response could have been achieved. Also, if we use bioremediation technology, we will be able to completely break down the remaining oil in faster time, in short time. So in summary, in the initial response, actual response was usage of booms and dispersants, but the problem was that the booms were too small and weak to withstand harsh weather. So we suggest larger and stronger booms. And for the coastal removal, they use sorbents and buckets, but these methods requires manual cleaning, which requires labor workload increase. So we suggest to additionally deploying skimmers that could be applied in complex shoreline and shallow water. And for the residue removal, we recommend using the bioremediation, which will accelerate the degradation of the remaining oil. The third step is to determining the product selection and cost and time based on the decision of cleaning method. So first, for the initial response, we recommended larger and stronger booms. And according to experimental results, the boom height should be higher than 42 inches, and the tensile strength of the boom should be larger than that number to withstand harsh weather with high tides. So our search results among the products, we found that the Lamor HDB has the most efficient, most higher height of boom height and the largest tensile strength. So we chose that product as the product we should use. For the coastal removal, we recommended usage of skimmers. Among many types of skimmers, the rolling and suction skimmer are appropriate for shallow water and complex shorelines. So we searched products of these kind of skimmers. And it turned out the Marlin shallow water skimmer was the most efficient, most appropriate one for skimming oils in very shallow waters up to depths of 7 centimeters. So we chose that one. And for bioremediation, one point is that this heavy spirit accident occurred in December, which is very cold weather. So we had to find the chemical that reacts normally under low temperature. And these two chemicals turned out to be appropriate. For the cost and time calculation, we observed the accident conditions and made some simplification for calculation. And we assume that the provided budget by the customer is as follows. These are the equations used to calculate the cost and time for each response sequence. And if you have questions, you may ask after the presentation. I'll explain. And one point is that the initial response in time, T0, is very important for reducing the cost and time decision. The total cost could be calculated by the sum of the three sequence costs, and this should be smaller than the customer's budget. And the calculation turns out the number of skimmer, large N, should be 90 under the budget. And the total removal time could be assumed at the time of coastal oil removal only, since it is much larger than the initial response time. And the calculation turns out that it requires only 4.5 days with the full operation of the 90 skimmers, which is much smaller time with the usage of only main usage of sorbents in the actual case. And for the residual removal time, with the use of bioremediation, according to the study of Kim, it will only take 155 days for 90% degradation for the Hebei Spirit shoreline, which is a great reduction in time. So by using our guideline, we were able to provide specific number of costs and removal time and a specific type of product and how much we need. We need 25 kilometers of booze and 90 skimmers. Of course, this is a very simplified model, but in the future, we may be develop more complex consideration. In summary, we developed a service that offers more clean response guideline requested from everyday customers who are concerned with waste. And the developed guideline was applied to oil spill accident from the history and showed its capability of providing improved and more appropriate methods, products, and costs. In the future, we may, with more complete information of given condition and subdivided criteria, and more precise modeling of cost and time, we may be able to produce a more accurate predicting guideline. Thank you. This is the job allocation. Thank you for this.
All right, thank you very much. Questions from other team members? No, then TAs?
This TA check, I had no specific comments or question. I was impressed that your group solves some specific problem in step by step. You suggested a lot of choices and you made a choice to for the best option. So I really like that approach. This is
Yeah, I also like the presentation, including the detailed calculation of the financial cost aspect. But the only thing missing is that it would have been better if you also address how much money the company could make with this business model. That's the only thing. And I have one question about this bioremediation. And so, has it ever been like practically used in real situations?
Yes, it is very widely used technology, but since the heavy accident was in the past, and since we have never experienced such large oil spill in Korea, the responding was very poor at that time. So there was many criticisms about the response at that
So is that technology specifically for cleaning up the oil spill, or
Yes.
is there other usage of the?
Of course, there will be many applications for using chemicals by making some reactions, but bioremediation is, it is a specific way of degrading oil. It is very widely used technology.
Okay, thank you.
I have two comments. One is, it will be nice if you provide a table or summary of pros and cons of alternative methods. You explained, but there is no summary of something like a table. And second one is, can I see the page 23 again? And you mentioned about the initial response time T0 is very important, right? So you need to include this initial response time into your guideline somehow.
Okay.
All right, thank you very much. So then we may move on to next team. Team Ho. Right.
Hello, I am Seungmin Lee from Team 4, and our team's object is mapping the ocean with AUV, bathymetry. Our original proposal was finding new method to map the sea using AUV. Currently, the ocean seafloor mapping is not complete, and most of the price is remained as unmapped state. AUV is one of the most common methods to map the sea. So we choose the AUV as the mapping method. So the previous presentation, we suggest several candidates for sea mapping. Among them, we choose the Arabian Sea, which is between Arabian Peninsula and India Peninsula, which is remarked in the red square. We chose this price because near Arabian Peninsula, there are many oil and gas deposits. So we thought that this price is appropriate for considering its economical value. First, in the previous presentation, we said that to mapping the sea with AUV, we should consider the plant. So we thought that how about the mapping entire ocean based on sea current without AUV velocity? We assume that AUV maintains its electricity to maintain its velocity, maintain its buoyancy, and remain in neutral velocity. We choose domain from latitude 10 to 12 and longitude 60 to 70. We use the sea current velocity data from World Ocean Database. We set simulation time of 320 hours, and we simulated at depth of 1 kilometer. We deployed 9 different AUV in certain distance. First, we deployed AUV in almost similar same region with distance 1 kilometer. We can see that small difference in deployed place results in large difference in the path, as we can see in the yellow trajectory. However, most of the AUV is remained in latitude 40 to 16 and longitude 64 to 66. We increased the distance between deposit AUV to 10 kilometer. However, even though the deposit length is increased, but most of the AUV is still remained in latitude 40 to 16 and longitude 64 to 66. We increased the deposit range to 100 kilometer, but research was almost similar. The most of the AUV is in similar spot. Comparing to the entire domain, the place that AUV covered is quite limited. You can also even see some of the space that is near enough to initial AUV placement, but still not mapped by AUV. So it results in the simple conclusion that simple floating movement is not enough for mapping entire ocean map region for parallel region, like slow diffusion like movement and possibility of the missing zone. So for efficient mapping, AUV itself must move. So because AUV should move, we should consider the houses. For AUV design, there are 3 kinds of the major houses, including lithium-ion battery and fuel cell and solar power. On them, actually, solar power is quite inappropriate for sea mapping AUV because solar power can be charged on the surface of the sea, but sea mapping AUV should stay under the sea for quite a long time. To find which power source is most can maintain the AUV in powered state. So we found the metric named entrance. This indicates how much AUV can stay under the ocean. It is actually there are many factors that affect on endurance. For submarine, the amount of the food or water supply could be one of them. But for AUV without any human, it is usually dependent on power consumption. This is the ratio between anode capacity and total power consumption. Anode capacity can be described with the multiplication of anode density and anode source mass. When we assume that total volume of the power source is 1/4 of the entire volume of the system, we assume 3 power sources: lithium-ion battery, solar power, and fuel cell. When using the energy density and known drag coefficient of major AUV shape and the speed of the ocean current for 1 meter per second, can see that fuel cell is most efficient, can stay AUV under the sea for longer day. Even though not considering that its inefficiency and only considering energy density, solar power is still the worst selection of power source. Even though those difference is diminished as relative velocity of AUV increase, there are quite large difference between lithium-ion battery and fuel cell. To reduce the drag coefficient of AUV, I suggest 3 different shapes of the frontal design. The radius of the largest radius of the AUV is 0.5 meter and length is 7.25 meter. I set calculation domain as following. And when I simulate the drag force under the sea, the model 2 has the best least drag force, so least drag coefficient. So, and this research of the endurance for different model, it shows that model 2 indicate in the red line have the longest endurance due to smallest drag coefficient. So we examine the possibility of sea mapping relying on sea current, but this method is unstable and inefficient because it relies on initial position and possibility of missing region. So we conclude that sea current itself is not enough for AUV operation. So instead we found the appropriate power source and frontal shape of AUV operates in ocean, considering the drag force and power density. For considering drag coefficient, model 2 has the lowest drag coefficient, and fuel cell is more appropriate power source for AUV than lithium-ion battery. This is the reference, and thank you for listening.
Thank you. And questions from other team members? No. Then we move on to TAs.
This is Chair. I have 2 questions.
Yeah.
So you told us that the fuel cell has the largest energy density for AUV.
Yeah.
So what is the total amount of energy stored in the AUV?
Oh.
Then we can make some calculation based
Yeah.
on the slide 11. Okay. Then my main question is that I expected that lithium-ion battery would have higher energy density than the fuel cell, because fuel cell system includes a fuel cell stack and hydrogen storage tank. And in this case, it is undersea condition, so we cannot be provided with oxygen. So I think we should also include oxygen tank. So I'm a little bit curious that the fuel cell system has higher energy density than lithium-ion battery. So is there any reason that fuel cell system has such that high energy density?
Actually, I found this source from the internet, and that doesn't know about the AUV, but general system. So I think that considering your suggestion, then there will be some modification is needed to the energy density of the fuel cell.
Okay.
So next, what is the other question?
Only one question.
Yeah.
So energy, I'm asking about the energy density of the fuel cell system. You meant that from the literature survey, that value is from the literature survey,
Yeah.
and you can make some modifications. Okay, thank you.
I have one question. So I appreciate that you put a great amount of effort in simulation. My question is about the neutral velocity assumption for AUV. So does it mean that the vehicle moves with the same velocity with the ocean front?
Is it for the AUV trajectory? Yeah, this simulation assumes the neutral velocity of the AUV, so it means that AUV just stays the shape, not to flip, and it just follows the C current.
With the same velocity.
Yeah, same velocity with C current.
Okay, I think in that case, it would have been better if you also provided a Stokes number. Because in reality, the actual movement speed of the vehicle, even though the density is the same, it will be slower than the actual current surrounding, the vehicle because of the Stokes number.
Actually, it is true, but actually, this research shows that only even though it is ideal simulation, the C current AUV exactly follow the C current speed, it is impossible to mapping wide video using only C current. So I think that if this result is positive, I should suggest Stokes calculate the Stokes number and actual velocity of the vehicle compared to C current. But in this case, we thought that this is not necessary because it is anyway invisible.
Okay. And one comment is that you mentioned that the AUV is already the most common method for C mapping. So I think it's better to change the name of the topic as optimization, the current AUV, rather than to this as a new method.
Actually, the method choice is done in the past proposal, so we just stayed in the name of mapping of the ocean with AUV because it is the initial title. So maybe I should change the title to the initial one.
Thank you.
Right, here's mine. It is nice to see that you choose the Arabian Sea. But if you see your scale map of say page 4, you showed us a scale of latitude between 10 to 20 and longitude of 60 to 70.
Yeah.
But I don't know how your scale of this latitude and longitude is comparing to the Arabian Sea. If you overlay this scale to the Arabian Sea, how much proportion of the sea is covered?
It is about it is about this region. I should maybe I should overlap the map in the modified version.
All right. Then you may say that about half of the ocean is covered by this scale, right?
It is cover
Okay.
about the half of the Arabian Sea.
All right.
Improved.
Good. Please provide the overlaid map picture later.
Yeah,
And then you are trying to deposit 9 AUVs at the same time together.
yeah,
So they are moving together. The 9 of AUVs are moving together
yeah,
to reduce the time to mapping.
yeah.
Okay. Then how many days you need to survey to cover the whole ocean or whole scale?
It is a good question, but I think that uh, it is impossible to mapping with 9 AUV in the because it is already it only covered a very small region of the Arabian Sea, and 320 hour is almost is normally longer than AUV's endurance. So I think that to mapping whole Arabian Sea, we should increase the number of the AUV when we only rely on current. So we decided that it is not feasible to use only relying on current. So we should add some power source and find the appropriate shape of the AUV to reduce the flat cost.
So you said this scale covers about half of the whole ocean of Arabian Sea.
Yeah,
And then if you use 9 of the AUVs together, it looks like you need to travel, say, for cover whole scale here. You may need several times of travel of small scale covered by AUVs. So that's why I asked you how many days you need to survey or cover the Arabian Sea or this scale. Anyway, it's better to answer this. And then final question is, what is the submerged depth of the AUV operation?
we also do that 1 kilometer.
Kilometer down to the submerged,
Yeah,
but it is too deep because there should be a shallow water. 1
yes.
kilometer is very deep, right? Why you choose to be submerged 1 kilometer down? My question is why you choose as a 1 kilometer of submerged depth of your AUV? Is there a special reason? It can be travel near the surface, right?
Yeah, but we should actually we also do that the sea mapping. So we thought that AUV should go quite close to the surface of the sea floor. So we choose that the depth quite deep. So when there is no picture, but when I surveyed some AUV design, they are designed to submerge during the mapping and go to the sea surface when the sea mapping is over.
And you need to have a say, depth map of the whole Arabian Sea first. So that you need to know how deep is the sea, the Arabian Sea. I guess there are maybe more than half of the sea is shallower than 1 kilometer depth. But anyway, you need to observe it. All right. Thank you very much. And then we move on to team 5, please.
이걸로 PPT 조정하는 걸로 하시. Okay. Okay, I'll start. Hello, I am Sung Yoon, and then I'll present about human detection for maritime accidents by using AI. This is a flow chart of our team project. We presented our first and second presentation before, and now I will talk about the AI and choosing the camera. Before I begin, let's take a look about what we did. In first presentation, we suggested the goal about detecting wrecked seafarers near the coast by using AI. But it has some challenges about if there are insufficient amount of training data, small target detection is really hard. In second presentation, we did to deal with the insufficient and low quality training data, we use a synthetic data set created by 3D game. But professor and TA commented about how about using the documentaries or films to obtain maritime accident data. So we covered in next slide. Okay, here is overall framework of our project. To deal with the lack of data set, a synthetic data set created by 3D game is used as well as a real data set. A deep learning based small target recognition algorithm was developed. Yeah. For trained data set, synthetic data sets from 3D games were used. In computer vision field, there are several papers about validating the synthetic data with real data set. And for real data set, real filming was conducted. With the help of Korean Coast Guard, I take a film at Ongjin, Incheon. And we use LabelMe software, which is a commercial labeling software, to label the image and object in the image. Okay, here's the detecting algorithm. The input of the algorithm is the image, and the output of the algorithm is detecting seafarer and the location of the seafarer. It would be too complicated to describe every part of architecture of the AI. So I'll talk about briefly about the architecture. First, wait a second. Okay. First, when input image is come, the fixed kernel plays a role of improving the signal to noise ratio of an object compared to its surrounding. Like they make some taken edges of the object, so it makes easier to recognize the object. And second, in feature extraction network,
It learns to separate target objects from the background by understanding the overall context. And finally, probability estimation network maps the probability of the requester being presented for each pixel. Here is the result of training process. The image below shows the deep learning network training process. As learning progresses, you can see that only pixels correspond to people are displayed in black. This here is the input image, and after corner and the feature extraction network, there are some objects, and actually the people on the probability of high probability of human was described in the final, like in here, like black pixels. And here's the video. You can see. Yeah. Here you can see the people walking here, and this is me. And after the person comes here, and the result is this. The white one is the human, and after the human comes from here, another person comes up here. So actually, they can distinguish human with the background. This one is stone, but the result can detect only human. This one also, there's a stone and human, but the result can detect only human. Next is the choice of camera and integration of system. There are some requirements of the camera. For the needs of the operation and their utility for night research, the camera should be infrared. To detect menacing, it has to have a high resolution and a sufficient range. To choose the location of the camera and the boat, we have to find a place where the best stability could be provided, and in the meantime, give the best place to scan the scene. The best option of system integration is a high place to avoid blind corner. The chosen solution is the development of the mast to integrate on the ship. To enhance the efficiency of the camera, the goal would be to implement it as close as possible to the middle of the ship. This mast will have to be easy of convenience, conceive, and easy of integration. Its purpose will be to fit the different rescue ships to be as modular as possible and spread easily in the different rescue team. There are plenty of infrared cameras available, but we have to take a certified one for maritime operation. The range of camera is different, and in catalog, their night and bad weather efficiency are not specified. If a gyro system is integrated, it will be better for wave noise. So we selected the camera, this camera, according to its specification sheet. It has waterproof rate of IPX6. IPX6 rate is resistant to strong water jets from nozzles in all directions. For when you have some smartwatch, it has the same degree of waterproof rate. And for valid rate, vibration and salinity, it satisfy IEC 60945 protocol. It is a global standard, international standard of marine navigation and radio communication equipment and systems general requirement. Also, it has gyro stabilization function was equipped so it can react to the wave noises. It can rotate every direction and incline 90 degrees. Yeah, for conclusion, in the first presentation, we defined the problem and goal. The problem was in maritime accident, it is important that initial alert should be as fast as possible. And not enough data set for detecting object in maritime and not enough data set for detecting object in maritime environment. The goal is build data set for detecting object in maritime environment and detect human in video from camera. In second presentation, we verified a synthetic data set. To deal with the lack of data set, we made a synthetic data set from 3D games. Several scenarios such as rainy condition, or fog, snow, night were used. A synthetic data is verified with pre-trained with real data AI model. And third presentation today, we deal with about the AI model and system integration. AI model is trained by a synthetic data set and a real field data set. Trained model can detect small target, in this case human, well in real field test video. System intervention on the vessels is considered based on the maritime condition, which is it should be impaired, corrosion resistance, stability, and etc. Thank you all, and here's our team members. Pierre Bertoch did about this camera selection and the in-system integration, and Seokjun An checked the AI model after the training, and me, I present now and designed the AI model. Thank you for your attention. See all of this today's presentation.
Thank you very much. Question from other team members? No, then TA.
So, how much accuracy are you expecting to this AI model?
The goal is about 85%. Yeah.
So it may have some error, and based on the detection, rescue team will go to the exit state. But if there is no any external person, who can be responsible for this system? My question is that after the detection, how would the rescue be more practical using this?
Okay. When the system, the camera, and in my opinion, the camera, the location of the camera can be shared with the rescue team. And if a camera detects a human who needs help, who needs to be rescued, then the rescue team member can go get the position where the human being is there. So like here, it can, okay, this is another field test about it can be human is here, and when the location of the camera is fixed or shared, then the rescue team can search where the rescue help is located, so they can rescue him. This is my opinion.
I have one comment. So seems like a lot of effort has been put into the project.
Mhm.
One thing that I want to see more from it is the actual application of the algorithm onto the maritime accidents, such as scenes from the movie. Like even though it currently might not work well, it was complicated and dynamic situations. That's what I want to see more.
Mm.
That's it.
And then like using about tiny pill like that. Okay, it could be used.
Is there any reason that you chose to use more of a stationary
Ah.
scene rather than the actual dynamic accident?
That's because it is just developing the system. So from stationary situation to dynamic situation. So this is the beginning of the project. So we chose the stationary situation.
Thank you.
Right. Here is mine. I also, anyway, it is nice to see the real field video from Ongjin Island. But also, I have a similar comment from Jihu TA that you suggest to place the camera at the mast of the ship, petrol ship, but the ship is moving so that there should be an oscillation, vibration, and shaking of the camera so that it is not easy to take the film. So you need to know, have a special method to stabilize that camera.
So
Yeah,
there's
right.
there's some wave noise about on the vessel. So we chose the camera which has wait a second please. With gyro stabilization function. So
Yeah.
and reduce the noise from the wave. There, so yes, wave.
Okay. Right. So the second one is you at the midterm presentation you proposed to have a synthetic film data from
Yeah.
animation or game. Did you try that data also, the synthetic data too, or not?
Yeah. Yes. So this here
Okay.
is the synthetic data set which is made by GTA 5, the 3D game, for daytime clear and daytime rain, night and clear and night and rain. And from these data, there's a pre-trained AI algorithm which is whose name is YOLO. That AI model is pre-trained by real data set. So if the synthetic data set is fit to real, then the YOLO algorithm can detect object in the image. So we check by YOLO algorithm for verifying the synthetic data set with the real data set.
Right. Anyway, so you had two experience with using synthetic data and also the real film video coming from Ongjin.
Yeah.
So it may be very interesting to show us what can be the difference between two different experience with synthetic data and real film. Do you have any idea?
I understand about your question with what is the difference between the synthetic data set and real field data set. Am I correct?
Right.
Uh, the reason for using synthetic data set is it is physically hard to get.
Well, I know the reason, but my question is what is the, how can I say, during the analysis process or training, there should be some differences. The output also, not the reason. Reason, I understand the reason using a synthetic data, but because you had a true experience, you may know there are some differences in treating the data, handling the data, and output of the data. Are they same, or is there any differences?
They're same in training process, because for training the algorithm, the training data set is composed of the game image and real field data also. So they're not they're labeled for just in the object are labeled, and they are trained to distinguish the object in the image, the real field image and the synthetic data image. So they are not
Not different?
yeah, no different in for
No
training.
different.
Yeah.
Okay. All right. Thank you very much.
Thank you.
Let's move on to the final presentation of Team 6, please.
Okay. Professor, can you hear my voice?
Right.
Okay. 이거 제 거 PC로 화면 공유를 하려고 하는데 여기서 강의실 PC에서 네, 잠시만요.
그냥 하면 될 거예요.
네. 혹시 PDF 파일
네,
보이시나요?
보입니다.
예.
보입니다.
그럼 진행하도록 하겠습니다. Hi, my name is Seung-Wan Yoon, and our presentation title is on the water construction. And in final presentation, we will provide to search for stable seabed in Korea and estimate feasibility. And before the start of our final presentation, let's review the midterm presentation. So this is comments from the midterm presentation. For the first and second comments, we will specify the problem by considering the hydrostatic pressure. And the third comment is we need to check the method of floating and lowering is really expensive than other methods. First of all, we have to clarify that this method is different from the floating method, and our project is to build an underwater structure to serve as a tourism habitat, not just to create a habitat. Therefore, this method goes through the process of floating and then lowering to make an underwater building. It costs more than other method, as we have to endure many enormous hydrostatic pressures in the process of lowering. In this part, we will specify the problem by determining the expense of off-site floating and lowering. Although it can be expensive, this methodology circumvents many costs associated with specified equipment and challenges encountering during underwater building. And structure is built off-site using modular building, and this modular building means assembling off-site and road using their own weight or on the bodies. And if needed, water is then pumped out structure after it is lowering into place. If filled with air, it functions similarly to a submarine, and because the air increases the construction volumes without increase its weight, its density decreases and floats, as opposed to filling the structure with water air within the structure would require more effort to sink, and then the center of buoyancy must be above the center of gravity to have an object sink. Regarding to the lowering procedure incurred, the materials would be determined and constructed depending on its resting depth. Point assuming its resting point to be the point of highest hydrostatic pressure. However, rapid changes of pressure can affect the structure. Pressure is force over area. A change of force over time is impulse. This is referred to as pressure fatigue testing or hydraulic impulse pressure due to cyclic load. This would best be discussed using fatigue strength as opposed to fatigue strength. Fatigue life demonstrates cyclic stress or resistance, and fatigue strength demonstrates maximum stress where it will not prematurely fail. And the regarding of the lowering produce incurred, the materials would be determined and constructed depending on its resting depth point, assuming its resting point to be the point of highest hydrostatic pressure. Sorry. I'm sorry. Fatigue S2 and curve of high strength, low or steel. Depending on what decision you make on the placement of the underwater habitat, how deep and how many cycles it will be subjected to decide maximum strength. And then in this part, we will specify the problem by determining the size of the underwater building and the depth of to be built. We determine the maximum size and depth of the building in consideration of the water pressure endurance. Hydrostatic pressure is the pressure that is generated by the weight of liquid above a measurement point when the liquid is at rest, and the height of a liquid column of uniform density is directly proportional to the hydrostatic pressure. And when a force acts perpendicular to the surface of an object, it exerts a noble stress. When a force acts parallel to the surface of an object, it exerts a shear stress. And when designing a building, it must be designed to be used within the allowable load. And so we will design structure size and depth which can withstand hydrostatic pressure for our project. So we use a raw steel's allowable stress in calculation, since most buildings use steel as support and actually withstands the most load. We determine the size and depth of structure by calculating the extent to which the structure can withstand water pressure. And to simplify the problem, we use some assumptions. First, we just consider hydrostatic pressure, not to pressure from current or waves. Second, we assume the 2D problem, or if the widths are the same, the left side and the front sides are the same problem. So the problem can be assumed to be a 2D problem. And third is seawater is constant density, and next pressure at the sea level is 1 atm, and finally we assume that the wall's thickness is 1 meter, which is usually used for skyscraper. And for the normal stress, the load of each wall is same as the rest distribution in the figure. For the side wall, we consider mean load, which represented by green line, and by our calculation, height is less than 2481.4 meter. And for the shear stress, we consider resultant force which exert on centroid. F1 and F2 correspond to the numerator of fraction in each calculation. By side wall shear stress calculation, height must be below than 43.6814 meter, and by bottom wall shear stress calculation, we can know relation between height and length, and this relation is shown in the next slide. This graph is showing the relation between critical ranks and depth. The critical ranks is the value corresponding to the boundary of the inequality from bottom wall shear stress calculation. We are free to choose the value corresponding to the area under this graph line. So we choose height will be 10 meter and length will be 60 meter. And however, there are many factors such as people's weight and internal facility weight and wave load. So even though we choose a value that is far enough from the graph, it should be designed to withstand a larger load in reality. To select the location of the underwater structure, we must consider ground stability. In this part, we will select the location by considering the sea depth, depth uniformity, and stability. This is a bathymetry of Korea, which shows depth of the sea. For our design, seabed depth is about 10 meters. If we mark the area where the sea depth is less than 10 meters, it is as follows. We will select the location among this area. Also, we need flat seabed to build a structure building. To know uniformity of seabed level, we consider two factors. First of all, when looking at the bathymetry, the area with a narrow spacing between the contours means that the seabed difference is high. Therefore, it can be just that the area in the red box is not suitable for building because the height of the seabed is not uniform. Second, the tidal wave affects the uniformity of seabed height. Tidal wave through the associated tidal current can contribute to erosion and deposition along the coastline. And strong tidal current is certain area can move sediments, leading to change in the seabed topography. Also, when tidal waves encounter the seabed, they can undergo refraction and other interactions with the topography. This may result in temporary changes to the local seabed elevation or morphology. And so in areas with large tidal waves, the height of the sea is likely not constant. And earthquake can be a major threat to structure. This map shows epicenter distribution for 1968 to 2022 in Korea. It can be seen that the area marked with the red box is the area where earthquake occurred frequently. When the previous considerations are put together, it can be determined that the area in the black box satisfies the appropriate sea depth and sealed uniformity and stability. So in conclusion, we decide the final location to the sea around Mokpo and Hanam. And let's see the estimate feasibility. We searched the underwater construction in Korea for economic analysis. This data is a reference to the Korean Institute of Ocean Science and Technology report. And table shows the construction costs required for the construction of an eco-friendly underwater tourism facility in Jeju Island. Detailed facilities include an underwater cable car and floating station. According to the report, when the usage fee is set at 30,000 to 50,000 won, in terms of profits from the use of the facility, it is considered that the relative profitability compared to the facility investment cost will be excellent. And we reviewed Korean laws related to the underwater construction. According to relevant laws and regulations, it is necessary to develop an eco-friendly underwater tourism facility based technology to foster a rich and vital ocean to pass on to future generations by pursuing eco-friendly and sustainable development and use of marine and fisheries resource. However, there is still a little interest in underwater buildings, and there is not enough discussion on this. So there seems to be room for amendment of the rule. So yeah, thank you for your kind attention. So, do you have any question?
Right, thank you very much. Any question to him from other teams? No, then TA.
Instead, I have one question. First of all, you have considered many things such as pressure and cost and regulation, and I was very impressed. And my question is that when you calculated the pressure for the building, you consider only one geometry, which is the rectangular, the rectangular shape. The picture on this slide shows that many several types of structure under the ocean. So, is there any reason why you choose the rectangular type for your pressure calculation?
So thank you for your good question. Actually, we do not specify the some shape of the construction. So I think if we consider the pressure, it's better to make the shape will be like this round shape. So yeah. So yeah, your comment is so good to consider some pressure. Thank you.
Yeah, I have one comment. The overall procedure was well structured and you covered a wide range of different aspects. And one thing is that please upload your PPT in the group chat by
Okay.
All right. Here's my comments. So you told me that the location is two places of Mokpo and the other one is Hanam.
Yeah, that's right. Yeah.
Where is Hanam?
You can see this right-hand side picture. Haenam.
Right?
Yeah.
Hanam. Oh,
Yeah, Haenam.
okay.
Yeah, sorry. Yeah.
Why Hanam?
Because we consider the stability on seabed. Yeah, so that place has a stable seabed.
But you need to have a customer, resident. See, if you want to sell your habitat or apartment underwater, you need to have a market or customer who want to stay there, right?
Yeah, actually, our proposal is about construct underwater tourism facility. So
tourism.
Yeah.
Then you need to find out good place for tourists rather than stable seabed.
Oh, that's a good point. So I think there's some.
So I guess you don't make any calculation on size of the construction building habitat. How many people will be stay there or something?
Mm, actually, I do not search about that, like, how many people can visit there, but, yeah.
All right. So you need to, so it depending on the demands and
Yeah.
tourist and size also and location also. They are all related.
Mm,
Anyway, thank you very much for your presentation.
thank you.
Thank you. So every team, please upload your modified slide set by midnight today. Then TA, two TAs and myself will grade afterwards. And thank you all for the presentation and all the attendance to this class. I was happy with you throughout the semester. Sorry for not with you today. I'm in outside of Daejeon. Thank you very much and see you around afterwards. This is the final class over. Okay, bye now.